All right, today's lesson is solving systems of linear inequalities. To solve systems of linear inequalities, you do the following. Number one, graph the boundary lines. Two, we're going to locate the section of the graph where the points are solutions to both inequalities. And then you want to shade that section of the graph. And that shaded section where those ordered pairs or solutions to both inequalities are called the solution sets. For example, graph y is greater than 4 and x is less than or equal to 2. So in order to do that, you must graph y equals 4. That's my boundary line. And you must graph x equals 2. But now be careful. We're not including numbers that are equal to 4 or less than 4. So we're going to use a dashed line to represent this line. And the second inequality, x is less than or equal to 2, including ordered pairs that are less than, the x coordinate must be less than or could be equal to 2. So we're going to use a solid line because we're including all points that have an x coordinate of 2. All right, so when you do this, this is going to represent x equals 2. And this is going to represent y equals 4. And what you want to do is shade to the left or right. So this one was all numbers that were less than or equal to 2. The x coordinate must be less than or equal to 2, so you're going to shade this direction. Shade this direction. And in the other one, the dashed line, it said all numbers that are strictly less than 4. Strictly greater than 4, I believe. Let's look back. Strictly greater than 4. So you're going to shade up. So everything above the line, you're going to shade up. And you want to find where do the ordered pairs for both inequalities intersect. And if you look at the graph, you'll notice that this section here is where they both, all the ordered pairs intersect at. So you're just going to pick ordered pairs from that set, but you're not including the points on the dashed line. Solid line, you can pick points from that and all the colors, all the other spot in the colored section. All right, graph x plus y is greater than 3, and x plus y is less than or equal to negative 2. Again, the boundary line will be x plus y is equal to 3. And you're going to use a dashed line because you're not including points where the ordered pairs have a sum of 3. You're including those that are greater, that have a sum greater than 3. You can use a dashed line for that graph. And the second one is x plus y is equal to negative 2. But you're going to use a solid line because you're including those ordered pairs that have a sum of negative 2, as well as those that are less than negative 2. All right, so when you graph that, you're going to have these lines. This represents x plus y equals 3. And down here represents x plus y equals negative 2. Okay, so this graph you're going to shade above the line because you're talking about all ordered pairs that have a sum greater than 3. But you're not including the ones that equal to 3, so you're not going to not including anything on the line. So you have to have a dash line there. And the other one said you want to all ordered pairs that are less than -2. So you're going to shade below the line. If you notice, they don't intersect. So there's no solution for this set of inequalities because there's no part of the color that intersects. They go in opposite directions. Okay, solve the system x plus 2y is greater than or equal to 8, and x minus 2y is strictly less than -4. Again, you need the boundary lines. So you need to graph x plus 2y equals 8. We know it's going to be a solid line because you're including every point on the line. And then the second one is x minus 2y is equal to -4. You're not including the points on this line, so you can use a dash line for that. Okay, so the boundary lines for the solid one, this represents x plus 2y equals 8. And for the dash line, this represents x minus 2y equals 4. Remember, we're not including the ordered pairs on this line, that's why it's dashed, but we're including the points as part of the solution on the solid line. Now you just have to shade up or down. Let's start with the solid line. That was x plus 2y is greater than or equal to 8. So we're going to have to shade above the line. So we're going to shade everything above this line and including points on the line. So it goes this direction. And for the second one, this is x minus 2y is less than 4. So you're including all the points below, but not on the line, but below this line. So all this is solutions here. All right, so if you look at it carefully, it's just this region that is a solution. But you don't include the points on that dash line. But you can include points on this part of the line as well as on out throughout the graph. So this is our solution set in the green. All right, graph x is less than 1 and 2x plus y is greater than 1. All right, so our boundary line is going to be x equals 1 and 2x plus y equals 1. They're both going to be dashed lines because we're not including points on the line. This is strictly less than, this is strictly greater than. All right, so the vertical line is the boundary line x equals 1. And the slanted line is the equation 2x plus y equals 1. All right, so we're talking about numbers that are less than 1, so you're going to shade to the left. You can shade everything to the left of this dashed line, but not including points on that dashed line. And the other one is going to be greater than 1. 2x plus y is greater than 1, strictly greater than 1. So you're including points above this line, but not on the slanted line. So this is how it's going to be. And notice where they intersect at is this little region here. You're not including the points on the line though, but just all the points in between that don't touch those two lines and everything in between. This concludes our lesson for today.